Hi, welcome to At the Helm of Kubernetes, repeatable infrastructure creation for mere mortals. I'm Rob Richardson, and we're going to talk about Kubernetes, building YAML files, templating and packaging those, and making them really easy to distribute. Let's dig in. Here's the part where I tell you I'm definitely going to post the slides on my site tonight. You're going to go look on my site tomorrow, next week, next month. In about 3 months, you'll get tired of waiting and you'll email me. In about 6 months, I'll reply and say, no, I'm definitely going to post them on my site tonight. I've been that person searching for the slides, and it didn't work out very well for me either, which is why you can get them online right now. If you head off to robrich.org and click on presentations, you'll get to here where you'll see Kubernetes at the helm of Kubernetes at the very top. And you can click into not only the slides for today, but also the code on GitHub. It is all online right now. While you're here on robrich.org, click on About Me and you'll get to this page. Here's a few of the things about me. Thanks for the introduction. I'm a Microsoft MVP, a friend of Redgate. AzGiveCamp is really fun. AzGiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AzGiveCamp. Or if you'd like a gift camp in your area, hit me up on email or on Twitter, and let's get philanthropy installed in your neighborhood as well. Here's some of the other things that I've done. SQL Source Control Basics. Mine is Chapter 8. That was fun. I do training of Docker and Kubernetes, Git, ASP.NET, and Node, React, and Vue. I was on the Gulp core contributor team in version 2 and version 3. And one of the things I'm most proud of, I replied to a .NET Rocks podcast episode. They read my comment in the air, and they sent me a mug. Woohoo! So that's my claim to fame, my coveted .NET Rocks mug. Let's dig into Helm and Kubernetes. So we talked about this guy, Helm. Helm is a package manager for Kubernetes. It allows us to build template YAML files, build packages that we can install, and share these packages with others. But wait, doesn't Docker already do this? Well, yes and no. Docker solves all of the complexities of installing an application on a machine. But then we end up with a whole lot of YAML files as we go to install this on a Kubernetes cluster. We may have a deployment and a service and an ingress, a user, a PV, a PVC, and collecting all those pieces, that's what Helm does. It creates that mechanism to take all of the Kubernetes resources associated with this image and deploy them in a single package. So I still need a Docker registry or Docker hub. I don't need all of those YAML files. All those will get packaged together into what Helm calls a chart. A chart is Helm's package manager format. So let's dig into some demos. I have here a website. Now this is an ASP.NET website, and so I have controllers and views and all of the different pieces. I also have a Docker file. Now this Docker file is a pretty standard Docker file for an ASP.NET website. We do all of the building of the project. We do the production deployment of the project. And if I build this, I end up with an image that I can deploy now into Kubernetes. So that's great. I have my Docker file. And now I have the Kubernetes YAML file. And this Kubernetes YAML file is, well, there's a lot of redundancy here. At the Helm is the name of my piece, and it's also the name of my image. And well, we can see that it's, duplicated a bunch of times. Add to that, the port 80 is duplicated a bunch of times. We have a lot of redundancy here. Let's see if we can solve that. So first, let's create a folder in here, and we'll call this chart. And inside the chart folder, we'll create a new folder and we'll call that templates. Okay, so we have our charts folder and our template folder. Now there's nothing magic about calling it chart. I could call it anything, but it kind of keeps all of the Helm resources together. Inside chart, I'm going to create a new file and I'll call this values.yaml. Here in values.yaml, let's collect all of the unique things that are part of this YAML file. Okay, first up, we have a name at the helm. Okay. Service type of node port. So service type of node port. We've got port of 80. We'll duplicate that all over the place. Into deployments. Ooh, replicas. That may be different between different projects. We've got the version of image label. In this case, we'll call it image label. Yeah, it's a version, but not really. We have a registry URL. And there's our port 80 again. Ooh, we have a bunch of resources. Let's grab all of these resources. These resource limits will allow us to cap our container in interesting ways. As we move into the ingress, we have some ingress annotations. And we may have other annotations depending on our deployment of choice. We have the ingress host. And here's all of the pieces that are different between our different applications. Now, we also may not expose some things publicly. So ingress enabled, let's say true. These are all of the things that are unique about our Kubernetes YAML file. And these are the things that we probably want to keep track of when we're creating a YAML file. All the rest of the pieces are kind of boilerplate. Okay, so now that we have our values, let's create some templates. I'm going to create a new file, and this will be ingress.yaml. And we'll grab the ingress piece out of here, and we'll set it in place in our ingress YAML file. Perfect. Let's grab another new file, and we'll let's add this file. New file, deployment.yaml. And we'll grab the deployment pieces out of this. So let's grab all of the deployment and set it here in deployment YAML. Now, when we had the one big Kubernetes YAML file, we probably put it into one file just so that we didn't have to worry about all of the pieces. But now that we're starting to scaffold them together, we can service.yaml, we can break them out into all of the pieces. Now, right now we're only templating a deployment, a service, and an ingress, but we could also deploy other things like users and roles, secrets and config maps, PVs and PVCs, anything in Kubernetes, any YAML resources, we can build this way. That's perfect. Now that we've got all of the pieces in place, let's start to wander through this template and centralize all of the pieces that we need. Okay, so first up in our deployment, at the helm. This is all over the place. Oh, we do need one more file. Let's reach into the resources where we built this last time, and let's go grab chart.yaml. Chart.yaml is that one more piece that makes Kubernetes work, and it kind of gives us some of the details about the chart. We'll have an API version, a name, at the helm, that feels like a good name. Description, at the helm of Kubernetes sample app, perfect. There's two different types of charts. One is an application. This is a package that we deploy, and the other is a library where we could use this as dependencies for others. Maybe it's centralized functions or shared resources. We'll have a chart version. This is the version of our chart, and this works with semver, semantic versioning. So every time we deploy a new version of our chart, we'll want to increment this version. We also have an app version, which is completely separate. It has nothing to do with our chart version and represents the version of our application. So why do we have two? Well, so that if we need to increment our chart, but our app doesn't change, then we can do that. Maybe we're updating other dependencies like the base image or other dependencies in our application. So we have this name, so we probably don't need a name here in values, but we still do need all of the other pieces. Let's come back now and start to remove some of the duplication at the helm. Well, we can swap this out with .chart.name. Now that'll pull this value out of the chart's name field and set it in place right here in this template. We can do this in all of the places where we have at the helm. Let's just go replace them all. Bam! That's cool. We don't need to specify it lots of times in all the places. Helm will take care of that for us. Version. Okay, let's grab the .values.image label. Very nice. Replicas. .values.replicas. Now there's nothing magic about any of these keys that I put in values. I'm just referencing the details in that YAML file. Here we'll use .values.registry and image label. Let's go grab the image label from here. Perfect. We'll put a quote around this just so that Kubernetes and Helm know that it's a string and not, other things. Port. .values.port. And that is great. Let's look at our service. Here in our service, yep, we've still got at the helm in all the places. Let's also replace type with .values.service type. If we flip this to load balancer or client IP, we can just do that in one place and it'll take effect. Okay, .values.port. Perfect. And let's do the port there as well. Wow. Most of the service is just boilerplate to make all the things work. That's cool. Ingress. Let's do the same thing here. We'll go for .chart.name. And here we'll do ingress host. .values.ingress host. What's the service name? It's .chart.name. Here we've got .values.port. Cool. So we've eliminated a lot of duplication in our YAML files. Let's check to see how this is going. Helm lint. Have we made any typos? Ooh. Helm lint, and I need to specify the folder name. So in this case, I called my folder chart. Okay, so here in ingress, we have an error in the port. Where did we do that? Ooh, values. Okay, that was an interesting typo. Helm lint chart. Yep, everything looks great. So now let's start to level up our chart, our package. Now, one of the things that we noticed was that we don't always want an ingress. So we can say if .values.ingress enabled. If ingress is not enabled, this entire thing won't get rendered. Now we're just using standard Go templating here. So, anything that works in Go works here. Great. Now we may have multiple annotations here. So rather than enumerating each of them, let's replace this with to YAML.values.resources. Now it's going to go grab all of these. Oh, this is not resources. This is ingress annotations. And we want to indent it 4 spaces. So let's say an indent 4. Okay, so it'll grab all of the pieces from here and set it in place right here. That's great. Now we want to do annotations. We also have this big resources section here in the deployment. let's do that here as well. We'll say here in this resources section, we want to do values resources. And now we want to indent 10 spaces instead of 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. That will get it indented correctly. So we've got all of the pieces in place. One other place where we do want to level up, though, is right here. If we don't have a registry, for example, we're using a local container, then we probably don't want this slash. So let's come in here and let's say if.values.registry. Then we'll do .values.registry and the slash. And then here we'll say end. Okay, so if we have a registry, we'll dump the registry and the slash. If we don't have a registry, we'll just start at the chart name. That sounds great. Let's do another Helm lint and make sure it looks okay. Yep, that looks great. Now we could scaffold anything. In this case, we only scaffold a deployment, an ingress, and a service, but we could scaffold any other resources and any details. To that end, we could scaffold any YAML file. That's perfect. There's one more thing that we can scaffold built into Helm, and that is notes.txt. Now this is the instructions that we give once you finish installing the package. So let's go grab the notes.txt and set that in place. Here's notes, and we will put it here in the template. Now this note just says, hey, thank you for installing chart name, version, chart version. You can use it in this way. Here's the release name that you chose as you installed it. If values.ingress enabled, you can go grab the browsing by going to ingress host, and we're going to default to localhost if you didn't specify one, and values port. But if ingress is not enabled, then you'll need to go get the IP from the service and connect to the service. So we have all of these instructions that we can just show the user as they start to connect to the service. And again, it's just a Go template. This is perfect. So now that we have all of the pieces in our chart, we can start to scaffold this into place. Okay, so how do we run this? Helm template, and then we'll specify the name of our folder, in this case, chart. And here's all of the pieces that we scaffolded. Here's our service, and we can see all of the pieces in place, all the port numbers. Here's our deployment, and we've got all of the pieces in place, and our ingress. Well, let's take a look at it and save it to dist.yaml. Okay, now that we've got dist.yaml, we can diff dist.yaml against compare to dist.yaml and Kubernetes YAML. Let's actually use beyond compare for this. So here we will go grab the dist.yaml and the k8s YAML, and we will compare. Okay, so here on the left is the file that we generated, and here on the right is our original file. We can see some comments that Helm added specifying the original file name. We see that we've got quotes around the image now, but we did great. We were able to template out all of the pieces of this YAML file, and we avoided all the duplication. The critical pieces in our application are right here. These are all the details that we care about. Everything else is just the boilerplate. That's perfect. Now if we need to adjust things, we can adjust it in one place, and everything will work out just fine. Okay, so we could do something like this. Helm template chart, my folder name, and I will redirect it. Oh, I redirected it to dist, and we compared it, and it looked great. But now we have some places where I think I'd like to add some things. Like here's the AKS URL, and here's the image label. I'd like to set those on the way through of templating them. Okay, Helm template chart set image label equals v0.1.0. That's the tag that I put as I built my image. And ingress enabled equals false. Now when I template this, you notice that we don't have an ingress anymore, and we've specified the version in all of the places. That's perfect. So if we wanted to apply this, then we can do set image label. We'll say, in this case, ingress host equals quote quote, registry equals quote quote, and we could redirect this to a file and then kubectl apply that file, but why not just kubectl apply -f dash. This will take that Helm chart and pipe it straight into Kubernetes, and kubectl get all. We can see that we've got all the things. We got our ingress created with no host name. We've got one replica. Let's take a look at our application running on this node port. So let's head out to localhost :30322, and up pops our application. Perfect. Now we were able to apply that just by piping it into kubectl apply, and it will go grab all the details. Just as easily as kubectl apply, we can kubectl delete and remove all of those resources. Kubectl get all, and we see that all of them are gone. Well, except for the pod that's still terminating. That's perfect. We can create resources, we can delete them, we can template them really easily, focusing only on the critical details that we care about. And we can scaffold out anything. A service, a deployment, an ingress, a user, a service account, a secret, a config map, anything that we need to scaffold into place. Well, now we end up with all of those details. Can we package them up and distribute them in one piece? Let's do that. Helm package chart. When we package this chart, it's saved to this file. Let's do that again. Helm package chart. It's saved to @the-helm 1.0. 0.1.0. 0.1.0 is the version that we had, and there's that file right there. Well, let's delete that and let's add a few more things. It would be nice if we're in the middle of the build, if we could set our app version. This will be 0.1.0, set our version. This is our chart version. In this case, we'll say 0.1.0 again, and set our destination to the dist folder. Cool. We put that new file in here, and we can take a look at that content. Now, if we unzip it and then unzip the tar inside, then we can compare the contents in this chart with our original chart template, and we can say that we've got all of the pieces set in place. There are no differences in any of these other files. Now, it did remove a little bit of white space in the chart.yaml. That's totally fine. Okay, so now I'd like to pass some parameters in here. I'd like to say Helm chart package --set and do some interesting things, but unfortunately, Helm package doesn't have a set argument. I can't override any of the values. Well, I could do some sed magic with the values.yaml file. That's a little heavy-handed. Instead, let's take a look at this, the Helm pack plugin. Now, the Helm pack plugin allows us to do exactly that. Once we install the plugin, we can do Helm pack --set and do all the things. So let's grab this Helm plugin. And in my case, I've already installed this Helm plugin. So let's Helm plugin list, and we see that that pack is already there. So instead of package, I'm going to use pack, helm pack, my folder, chart, --app, version 0.1.0, version 0.1.0, destination, dist, set, and in this case, I will set some interesting things. Let's set the image label to be v0.1.0, the registry to be blank, and the ingress host to be blank. Now, if we're going to override all of these every time, then maybe we'll go back into values.yaml and blank them out. But having a build set these three version numbers is perfect. And this one doesn't need to be a version label. It could just as easily be a git hash. But this one does need to be semantically versioned. Okay, so we packed that into at the helm 0.1.0. Let's unzip that again, or untar it rather, and take a look at the files that we've got. Untar this one, extract here, and let's use beyond compare again to compare this one to the chart. Now we're hiding all of the files that are identical, so we don't see any of our template files. They didn't change. But here in their values, we see that, well, it reordered them. They're alphabetical now. But we have registry set to blank instead of set to ACR URL. Ingress host is blank as well. And our image label is set here. So users can override this as they install this Helm chart, this package. But this is a good default, and this matches what we had set in our Docker build command. Okay, so we've got this in place. Let's go build it again. Great, we've got that package. Now let's install it. Helm install my app. I'm going to give it a name. This is the instance name that I want to put into place. I'm going to specify the file that I've got, dist at the helm, and I can say set ingress enabled equals false and replicas equals 2. I could override any of the values in values.yaml. In this case, I'll only override these few. Okay, so I installed and it gives me the instructions. Thanks for installing at the helm version 0.1.0. You chose to name this instance my app. To see your resources, run helm status my app. Helm status my app. Well, that's exactly what I just got. That's perfect. Helm get all my app. Here's all of the YAML files that it created. So here's the deployment, and here's the service, and here's the ingress. And if I kubectl get all, I can see that I have those two pods running. I have the service up. Here, there's no deployment, or there's no ingress because I didn't create it. But let's go connect to this node port and take a look at our application. Just like before, our application is up and doing just fine. That's cool. Helm list. Helm list. Helm list will show me all of the Helm packages that I have installed. In this case, I have my app installed. It currently hasn't changed. It's only revision 1. Here's the date and time I installed it. It is deployed, and here's the original chart and app version of the content that I installed. That's cool. So now what if I want to upgrade this? Well, I can say Helm upgrade my app, and I can point to the file that has the new package. Now, right now it's exactly the same, but once I upgrade it, it will replace all the resources that it needs to. If I say Helm list, I can see now I am on revision 2. So whatever resources need to get recreated or altered, it will just do all of that behind the scenes for me. That's perfect. So one of the things that we see, kubectl get all, is all of the things are named at the Helm. So what if I wanted to, say, install 2 of them? Well, if I was to install the second one, it would fail to install because that name is already in use. Well, we can definitely solve that. As we installed it, it said, hey, thanks for installing this. You chose the name instance my app. Okay, so here inside notes.txt, we reference that with release.name. Well, we can go through each of these things and alter their names to say, hey, this name is the chart name dash release name. The replicas, that won't change. The match labels, we do want to change the match labels. So let's say release and give it that release name. This metadata labels, we'll give it the release name. The containers won't change. The registry won't change. We're still pulling the same image. Here in the service, we'll also give it the service name. We don't need to change anything else, but we will add release and that release name. Perfect. Here in Ingress, we'll come into Ingress and we'll also give it the release name. We also need to point it to the service with this release name. And now we have a new version of our template that will create unique resources for each thing that we deploy. Because we appended this release name into all the things, now we can build up a new thing. Okay, so let's package this up. Helm pack chart app version. Well, our app hasn't changed at all, so 0.1.0, but our chart has changed. So this one will be version 0.1.1. Destination will still be the dist folder, and we'll set some defaults here. Image label is v0.1.0, registry is blank again, and ingress host is blank as well. Okay, now we've got this new version. Let's Helm install my app 2, and we'll point it at this .1.1 version of it. And let's also set ingress enabled equals false and replicas equals 2. Now we've installed a second version of it. If we say kubectl get all, we still have the old version with all of the just at the Helm named things, but we also have the new one that is named to match our release name. So now multiple versions won't collide. That's perfect. So if we suffix with the release name, we can install multiple versions of our application in the same Kubernetes namespace. So let's uninstall these. Helm list. I have these two installed, my app and my app 2. So let's Helm uninstall my app, and we'll Helm uninstall my app 2. Well, what were all the resources that were created with this? Do I need to remove users and roles and PVs and config maps? Nope, I don't need to worry about that at all. kubectl get all, and I can see that all those resources were removed for me. Perfect. The Kubernetes YAML files are a little bit verbose, and packaging them up this way means that I don't have to worry about all those details as a consumer of my package. Well, could I run other software this way as well? Let's head off to hub.helm.sh, which will redirect us to artifacthub.io. Artifacthub is the Docker hub of these Helm charts, these Helm packages. Now, this doesn't replace Docker Hub. Each of these Helm charts points at a particular image that will be in a registry, either Docker Hub or a private registry. But let's search these. So let's search for Nginx. Here's an Nginx chart, and what's interesting here as I go to install it, Helm repo add Bitnami. The interesting thing here is that Artifacthub is not a repository of charts. It is a repository of chart repositories. And the actual repository is this one owned by Bitnami. That's perfect. So let's grab this one and we'll set it in place. And I believe I've already added it. So yep, it says Bitnami already exists. That's perfect. Now let's go grab this Helm chart. I just say, hey, I want this Helm chart, and I'm going to name it this way. So I'm going to name it my Nginx, and I'll pull in this chart, this Bitnami/Nginx one. I don't need to specify the version in this case, but I could if I wanted an older version. I'll just go with the latest. Now, automatically, it's going to pull the image down from wherever that registry is stored and start it up. kubectl get all. And I can see that it started my service of type load balancer. And let's head off to that service and take a look at Nginx. So we'll go to localhost to this port. And here's my Nginx server. I didn't need to worry about any of the details of the YAML file. What was the service type? What was the details? I can definitely override anything in their values.yaml file if I need to. But all of the particulars of getting Nginx installed, those were all handled for me. That's perfect. Just as easily, Helm list, there's my Nginx, Helm uninstall in my Nginx, and it's gone. That's really cool. Now, in older versions of Helm, we had Tiller, which did all of the server side keeping track of what was installed. Now it's all handled with just regular Kubernetes resources. So these are just stored as metadata on the namespace to ensure that we have all of the features that we need. So where do we go from here? Well, we saw great demos of scaffolding out the Kubernetes YAML files, removing all the duplication and focusing on those few critical pieces that we needed. We saw how we could package up our YAML files into a single piece that was really, really easy to install and configure. We saw that we could consume others' packages from Artifacthub. Helm is pretty cool. We can scaffold any YAML file. Now, we could scaffold any Kubernetes resource, but we could also scaffold anything that is YAML. This isn't tied to Kubernetes per se. It removes a lot of the duplication in our Kubernetes YAML files. It doesn't prohibit us from using anything in YAML because at the end of the day, this is just a superset of the normal YAML details. Anything that we can do in YAML, we can do here. We can create all kinds of Kubernetes resources. And then we can identify the pieces that we need, configure them to do really interesting things, and spin up whatever resources are necessary for our application. Well, what's cool is we spin them up. What's a bummer is that's kind of where a Helm starts. It's about the install process. Any of the post-install processes are not really handled by Helm. Monitor, scale, heal. Now we could build resources that have those pieces embedded in their YAML, but we would need to build all those pieces. For example, we created a deployment and we specified a replica count of 2. So if one of those pods was unhealthy, Kubernetes would spin up a new one. But autoscaling or spinning up more things based on load or any other intelligence, we would need to build that ourselves. Well, what if we wanted to dig in there? Kubernetes operators are kind of that next level where Helm is just about agnostic YAML scaffolding. Operators take it to the next level of digging into all the pieces. There's 3 different ways that you can build operators with the operator SDK. You can build Helm operators, but for the most part, these Helm operators are only able to do installation and a little bit with upgrades. If you use Ansible, you can get a little bit further, but really to get the power of Kubernetes operators, you need to write them in Go. And, well, it's pretty involved. So the beauty of Helm is it's kind of a lot easier to get started and a lot easier to configure. And you can scaffold any YAML file, not just Kubernetes YAML files. If you want to take more control over that post-install experience, a Kubernetes operator is a really good choice. So Helm is really great for removing that duplication, helping us focus on only those critical pieces that are important to us. And we saw that we could template things. Helm template, we passed in our folder and set various resources, piped that to kubectl apply, and just launched it. If the purpose of our build is just to get this YAML file into place with setting some configuration values, then this is perfect. We don't need to create a package. If we'd like to share this more publicly, we can create a package. Helm pack, we pass in our chart path again, and set whatever overrides that we want to into our values.yaml. Helm install that package name will get it into Kubernetes, and that's a great way to get that package deployed into all the places. We could publish this to a public registry like Artifacthub or to a private registry as well. And to that end, once we're on Artifacthub, we can start to consume lots of public packages. Now these public packages, this Artifacthub is not a repository per se, but rather a repository of repositories. So Helm repo add whatever repository actually houses this chart, and then Helm install the instance name and the chart name from that repository. Template, package, and share. Helm is a really great tool for doing all of these pieces and allowing us to do really interesting things. Now we're not replacing Docker Hub. This is only simplifying the YAML experience. We'll still pull an image from a registry and start that in our Kubernetes cluster. It's really fun to get to dig into Helm and to eliminate some of that duplication. I'll join you in the conference's Q&A section, but if you're watching this video later, hit me up on Twitter at rob_rich, and you can grab these slides and code right now at robrich.org. Click on presentations, and you'll get to exactly the code that we built today and these exact slides. Thanks for joining us today.